Okay, so we're solving the problem 2349, design a number container system. So design a number container system that can do the following. Insert or replace a number at a given index in the system and return the smallest index for the given number in the system. So we have been given two functions, void change and find, where we have the index and number in the change, and we have to fill the container at index with the number, and if there is already a number at the index in the container, we have to replace it with the new number. And in the find function, we have to return the smallest index for the number, and if the number is not present, we have to return -1. So if you have given this problem a try, uh, you might have arrived at a solution that gives you TLE around 30, I think 38 cases or 32 cases uh, pass, and so it's not the most optimal solution. But what what troubled me was to find why was it not the most optimal solution. So the idea is to have uh, two dictionaries or hash maps. One maps the indexes to the numbers, so uh, that would be a default deck. uh, yeah, default dictionary, I mean, let's call it index to number, default dictionary of integers. So for each index, we only have one number. That's why it's integer. And it makes sense to have another dictionary of lists or arrays that store the indices for each number. So uh, we can have a number. So for the first example, the number 10 has multiple indices. So it has 2, 1, 3, 5, and 1 again. No, so 1 is for the 20. So it has 2, 1, 3, 5. So it makes sense to store those indices in a list, and then maybe we can perform some pop operation from the list uh, to find the smallest index. So for that, we'll have a number to index as a default dictionary, and we'll pass the type as a list. So if you go about solving it the normal way, what you would do is, you have this new index, you have this index and this number. So first you would go on to check if the index is already filled. So if it is, you just replace the number and you change the list so that the old index that is no longer valid is removed from the number. So that is fine, but that's one of the reasons why you get a TLE using that approach. Because when you try to uh, when you try to remove the old index, the operation that you do is O of n, time complexity. But there is an optimal way to do that. So you can go through the Leetcode solution. Uh, I mean the official solution they've given, and I think it's a pretty good explanation. The part two of that solution. So they call it the lazy updating, which kind of makes sense because so basically the lazy updating method is that you update the indices that are no longer valid in the find function itself. So that way, when you do that, the operation is O of k log n, which is slightly better than having to update it in the change function itself. So it will make sense as I go along. So one more point would be that we can use a priority queue to push and pop the number to index dictionary values. So when we have to, because we have to find the smallest index, it would make sense to use a priority queue to pop the smallest index. So uh, in this function, you have to basically do a normal update. So if you have an index, what you're gonna do is self dot index to number, and for this index you're just gonna update that number. And for number to index, you're gonna just push the new index to the priority queue, and you're gonna worry about the last index in the find function. So here you can do a push and self dot number to index number and just push the index here. So in the find function, first of all, if the index is if the number is not there, you can just return -1. So if self dot index to number of self dot number to index, so this will return an array. So the if there is no array, or you can do if length of this array if the length of this list is equal to 0, you can just return -1, and by default you can return -1. So if we have an array, we want to pop using the heap queue function. So we have to perform heap pop, and we have to check if that index is really valid or if it's an older index. If it is the old index, we can just discard it. So we can have a while loop here. While again length of self dot number to index of number is greater than 0. So while the array is there, we find the index is self dot number to index. So this would be the smallest, or the first index in the uh, list. So we can check that if self dot index to number of index. So whatever index that has been returned, is the number that the index points to really equal to the number we want. So if it's not equal, uh, I mean, if it's equal, we can just return it. So we can just return index. And if it's not equal, we have to pop it. So heap queue dot heap pop, and we pass self dot number to index of number. So that will pop mm, the the index that is not required, or the older index from the list, and then it can continue. So seems like it is fine. Let's give it a run. It works. Submit it. Okay. So yeah, this is the most optimal solution, and you can go through this editorial. So it's a pretty good, considering the Leetcode editorials are very bad. But yeah, so don't follow this approach, because I don't think they've used a sorted set, which I don't think is a part of the standard Python library, so it won't help you in an interview or something. So you can read the second approach. It is pretty good concept as well. All right, see you tomorrow.